Problem 3. The atmospheric pressure decreases with increasing altitude. At sea level, the average air pressure is 1 atmosphere, that is approximate 1.033227 kilograms per square meter. The table shows letter P that stands for pressure in atmospheres and letter H that stands for altitude in kilometers.
I go to anywhere I flow. Sometimes I believe, at times I wish.
Letter A. Use a graphing utility to find the model of the form P equals A plus B ln H for the data. Explain why the result is an error message. First, to solve this problem, we had to find A and B. These are the formulas for A and B. So we plugged in the numbers, and here we got that A was approximately equal to 0.798, and that B is approximately equal to negative 0.037. So when we plugged this formula A plus B ln H in the calculator and plugged in a 0 as H, as the altitude, it gave us error, and while watching the graph we found out that it was because there is an asymptote.
Letter B. Use a graphing utility to find the logarithmic model H equals A plus B natural logarithm of pressure for the data. First, with the formula, we input the value that we have gotten already, and we set a value for the pressure, and it gives us that the height at that pressure will be 0.798. So when the pressure is 1, the height, or x, will be exactly at 0.798.
This is our call. We rise and we fall, dancing in the moonlight. Don't
C. Use a graph utility to plot the data and graph the mobile. And here we just grabbed the data of the question and we plotted it in the Excel and we got the graph.
Letter D. Use the model to estimate the altitude when pressure is 0.75. With the formula H equals A plus B natural logarithm of pressure, we just plugged in the values and we found out that when the pressure is 0.75, the height will be 0.809 kilometers.
Letter E. Use a model to estimate the pressure when height is equal to 13. With the given formula, pressure is equal to A plus B natural logarithm of H. We plugged in each values, the value of A, of B, and of H, and we got that the pressure when the height is equal to 13, the pressure is 0.703 atmospheres.
Letter F. Use the model to find the rate of change of pressure when height equals 5 and height equals 20. Then interpret the results. First of all, we plotted the given formula that it's pressure equals A plus B in natural logarithm of height. We did the first formula and we got pressure equals negative 0.037. We derived it, and then we plugged in the height, the first height, that it's height equals 5, and we got pressure equals negative 7.4 times 10 to the negative third power atmospheres. Then we did the same derivation and got the pressure equals negative 0.037 times 1 over 20 because we got the second height given, that is height equals 20. And we got the amount of pressure equals negative 1.85 times 10 to the negative third power atmosphere.